Lesson 2 is about exact values for 0 degrees, 30 degrees, 45 degrees, 60 and 90 degrees. So exact values, what we're looking at when I find sine 30, sine 45, cos 60, and I actually would find those decimals, and we've been using 4 decimal places. What I'm going to do right now is find the values for all of these without a calculator, and we're going to have exact values. So we might see fractions and we might see radicals, but we're not going to have all the decimal places. So we'll come back to this chart in a minute, and we are going to fill it in, but to calculate a particular primary trigonometric value for an angle of 45. So here we go. The very first special triangle that we're going to look at is a triangle where the corners would be each 45 degrees. So if this is a 90-degree corner and this was a 45-degree corner, it would make sense that this also has to be a 45-degree angle here because it has to add up to 180 degrees. So this is really an isosceles triangle. We have one unit on either side, and then we would need to find the hypotenuse. A squared equals a squared plus b squared, and then we would have the square root of a squared plus b squared, and so that's just 1 plus 1, so the answer would be the square root of 2. Again, these are exact values, so we're not going to use a decimal for that. We're just going to leave it as the square root of 2. So this is a special triangle, okay, with 45-degree corners. So what we need to look at then, if we're using the sine ratio, I don't think you're going to find this hard, it's just different. Sine of 45, so if we're standing at either A or B, the sine is the opposite over the hypotenuse. So even if I'm standing up here at B, my opposite is still 1, and my hypotenuse is the square root of 2. So when I write this though, so this is an exact value, right? There's no decimals. If you actually wanted to calculate what this was, and then on your calculator you typed in sine 45, you would get the exact same decimal answer as you would if you did 1 divided by root 2. There's only one tricky thing, and that is we learned this before in the radicals unit. It's just not proper to have a radical in the denominator. So we don't usually leave those there. So what we end up doing to take care of that, we multiply by root 2 over root 2. And that's just like multiplying by 1. So we're not really doing anything to change this value. But what happens, 1 times root 2 in the numerator becomes root 2. The square root of 2 times the square root of 2 is just 2. So this is how we would actually leave our answer. This one here is not incorrect. It's just not a proper thing to have a radical in the denominator. This is how we fix that. We just multiply by root 2 over root 2. This is our proper answer. So the sine of 45 is root 2 over 2. The cosine of 45, if we look at cosine, if I'm standing here is adjacent over hypotenuse. Even if I'm standing up here, it's adjacent over hypotenuse, so it's 1 over root 2 as well. This is my exact value. But again, that could be okay, but usually we wouldn't leave that radical in the denominator. So we would get root 2 over 2. And then the tangent of 45, okay, the tangent of 45, if I'm standing over here, tangent is opposite over adjacent. So even if I'm standing up at B, opposite over adjacent, it's 1 over 1. So the tangent of 45 is actually just 1. If you go to your calculator right now and type in tan 45, you're going to get 1. That's just how we would get that exact answer without having to use a calculator. So that is a special triangle, and here are some of the values that we get. We're not going to do this for every angle, just for those that are listed here. These are kind of the typical measurements that are going to be useful for us to have. On the next page, we're looking at calculating a primary trigonometric value for an angle of 30 or 60. So if we look at an equilateral triangle, imagine that all of the angles in an equilateral triangle are all 60. So imagine this is just 60, 60, 60. It's equilateral, so each side unit is just 2, 2, and 2. So this is sort of our other special triangle that we need to look at. The units on the side are each 2 in measure. So then if we imagine splitting this triangle into 2 right triangles, that would mean that each side, each angle up here, they're both 30. So we have a 90, 60, and 30. That adds up to 180 degrees. If we're looking for this side of the triangle, we need to think about the Pythagorean theorem again. This time we know the hypotenuse, which is 2, so that would go here. And then we're subtracting this measurement here on the bottom would be 1, just like this side would be 1. So if I'm looking at just this triangle here, the hypotenuse squared minus 1 squared would equal this side squared. So if we take the square root of 2 squared minus 1 squared, we get the square root of 3. So this is root 3 on this side here, this height here, up and down. So we have this right triangle. If we're standing up at A, sine is opposite over hypotenuse. So that's 1 over 2. And I'm telling you, if you don't believe me, type sine 30 on your calculator, you should get 0.5. Okay, cosine of 30 is adjacent over hypotenuse. So we have root 3 over 2. And that's okay, there's no radical in the denominator, so we can leave our answer like that. Tangent of 30, so if I'm standing up at 30, tangent is opposite over adjacent. So that's 1 over root 3. But not proper to leave that in the denominator, so times root 3 over root 3. And that would give us root 3 over 3 as our proper answer. And then we move to the 60-degree angle, so opposite over hypotenuse is root 3 over 2. If we're standing down here at B, cos is 1 over 2. So just to test it out, type into your calculator cos 60 and you should get 0.5. And then tangent of 60, if I'm standing down here, opposite over adjacent, so we just get the square root of 3. So those are some special values for these special triangles. So this is our second kind of special triangle right now. Okay, and then there's a couple of sort of different things to think about. You're going to have to use your imagination to calculate a particular primary trigonometric value for an angle of 0. And I know you're probably thinking, well, if it's 0 degrees, how could it be an angle? But it's something that we kind of have to imagine. So if we have this angle theta, and if it's approaching 0, what would really be happening would be that this side here, the hypotenuse, would kind of be coming downwards, right? Imagine it flattening down to the ground so that this angle in here would be really, really small, and then eventually it would actually approach 0. So that's what this arrow means. This side y is actually getting smaller and smaller until it doesn't exist. It would be 0. I can draw one. It doesn't really help, but imagine this triangle is becoming sort of smaller and smaller so that this angle here is our theta angle, and it approaches 0. Our y is really going to approach 0. It's not going to have any height to it at all. And the hypotenuse r and our value on the bottom, if this side here is coming down flat, 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 and it's going to almost be right on top of the x, we know that the r value is going to actually end up equaling the x value. So that's what is over here. If I'm thinking of the sine of 0, imagine opposite is 0 over, so we have r equals x down here. So opposite is 0 over hypotenuse, r equals x. So that could be just r. 0 divided by r is just 0. And if you type sine 0 on your calculator, you're going to get 0 as an answer. Cosine of 0 is different. So cosine is adjacent over hypotenuse. Well, they equal each other. So we could write r over x or x over x because they actually are the same value, and we get 1. And if you type cos 0 on your calculator, you should get 1. And then the tangent, so tangent is opposite, which would be 0, over adjacent, which would be x. So opposite, 0 over x, that's just 0. So those are kind of different to imagine. It really does take some thought, but an angle of 0 has these values for their sine, cos, and tangent ratio. And then the last page, last new thing to think about. Imagine that we have an angle of 90 degrees. So I know that the right triangle, it does exist over here. Imagine that this value for the angle is actually getting bigger and bigger and bigger. And imagine this angle is actually getting larger. So that this value of r is kind of coming more straight up and down until it actually approaches a 90-degree corner. So when we're talking about how would you calculate without a calculator sine of 90, cos of 90, and tangent of 90? It really does take some imagination. So this r value is going to be extended over this way. The y, that means the y and the r are going to actually end up being the same height. So y is going to equal r. And eventually this length here would approach 0. So x is going to equal 0. Kind of imagine that this hypotenuse is coming up this way, and this is bringing our side length with it. So the x value ends up approaching 0. So let's think about, if you can picture that, the sine of 90 would be opposite over hypotenuse. So we would have y over r, but y is the same thing as r. So we could write that as y over y, which equals 1. The cosine of 90 is adjacent. Well, the adjacent it's approaching 0. So adjacent over hypotenuse is 0 over r, or 0 over y. And that just equals 0. And the tangent of 90, we do opposite over adjacent. So opposite, we could have y, and adjacent would be 0. But there is a rule in math that you can't divide by 0, so that is actually going to just be undefined. So if you type tan 90 into your calculator, it should probably give you an error. Cos 90 into your calculator would give you 0, sine 90 would give you 1. So what we're going to do with those values, let's fill this in. So this is something that some students memorize, or some students just try and learn how to find these values and just sketch the triangles to quickly be able to fill in this table, because you're going to be asked questions based on this. So one of the types of questions that we're going to do, it's just example 1 at the very end. So example 1, evaluate sine of 60 squared plus cos of 60 squared. This is just the way that it's written. So just note that sine of 60 squared is just written in that way. That's the same thing you could imagine as sine 60 squared. Okay, so it's just typical that this is the way you'll see that written. So what we need to know is, what is the sine of 60 and what is the cos of 60? So if you go back to your chart, sine of 60 is root 3 over 2, and the cosine of 60 is 1 over 2. So sine of 60 was root 3 over 2, and the cosine of 60 was 1/2, but it's squared. What's the sine of 60 squared plus the cos of 60 squared? And we're not really looking for decimals in this kind of question. We're looking for you to simplify, maybe get common denominators. So when you square something, you square the numerator and the denominator. Root 3 times root 3 is just 3, and 2 times 2 is 4. And then 1 times 1 is 1, and 2 times 2 is 4. So if I add that up, I get 4 over 4, which is the same thing as 1. So simplified, sine 60 squared, or sine squared 60, plus cos squared 60 is